In this video, we will be covering quadratics, which is section 1.5. The goal of this video will be to review forms of quadratic functions, go over the short run behavior, talk about solving quadratics, and look at an application problem. Quadratics are transformations of the function f of x equals x squared, which has the shape of a parabola. The standard form of a quadratic function is ax squared plus bx plus c. The transformation form, or also known as the vertex form, is a times the quantity x minus h squared plus k, where the vertex is located at hk. And because of this, that's where we often call this the vertex form. We want to write an equation for the function that's graphed. Notice that we are dealing with a parabola, so it is a shifted parabola form. So the base function would be f of x equals x squared. So we're transforming x squared. So one way to think about that is this would be a reflected graph that would be shifted to the right 2 units and up 7 units to get to this vertex of this upside down parabola. It's reflected because a normal quadratic function opens upward. So another way to think about this would be to look at the vertex form, which is f of x equals a times x minus h squared plus k, where h and k are the vertex of the parabola. So the vertex of this parabola happens at 2, 7. So we can plug those in to our vertex form. Now, if we want to find a, we just need to find another point on the graph, which we can identify as 3, 5. Alternatively, you could use 1, 5 as well. These are just easily found points on the graph. So I'm going to use 1, 5, and I will identify the point 1, 5. Alternatively, can be written as f of 1 equals 5 in function notation. So x equals 1 and f of 1 equals 5. So plugging that in, we have 5 equals a times 1 minus 2 squared plus 7, and we're solving for a. So I can subtract 7 from both sides and get negative 2 is a times negative 1 squared, or a equals negative 2. And we end up with the equation of this function as f of x equals negative 2 times x minus 2 squared plus 7. This is the vertex form, and if you wanted the standard form, you could multiply out the binomial and distribute. So if you want to multiply out the binomial to get standard form, you want to make sure to write the binomial twice, is what squared means for a binomial. And then you FOIL, and then you can distribute your negative 2 and add your 7. And so we have our vertex form and standard form of the same function. For short run behavior, we often are interested in the x and y intercepts of a function. This will be true for any time you want to find the short run behavior of any function that we'll be discussing throughout the rest of this chapter and in future sections. As with any function, we can find the vertical intercepts of a quadratic by evaluating the function at an input of 0. So that's when x equals 0 and it's crossing the y-axis. And we can find the horizontal intercepts by solving for when the output will be 0. Note that depending on the location of the graph, we might have 0, 1, or 2 horizontal intercepts. This is specific to a quadratic. We want to find the vertical and horizontal intercepts for the following quadratic function. So it's important to remember that for vertical intercepts, you'll set the input to 0. So in this case, you'll set x equal to 0. For horizontal intercepts, you'll set the output equal to 0. So to solve for the vertical intercept, we're going to set the input, or x, equal to 0 and evaluate the function. We're looking at negative 2 times 0 squared minus 14 times 0 minus 12, or negative 12. And so our vertical intercept is at 0, negative 12. To find the horizontal intercepts, we'll set the output equal to 0, which is g of x, and then we'll solve for x. So using the same terminology as we discussed in our first video about functions, for vertical intercepts, we are evaluating, and for horizontal intercepts, we're solving. So we'll set our trinomial equal to 0, and we'll try to solve our quadratic function, and you always want to attempt to factor first. Notice that all three terms have a common factor of negative 2, and if we factor that out, we're left with x squared plus 7x plus 6 equals 0. Our goal to factor the trinomial is to find two numbers that multiply to be positive 6 and add to be positive 7. Those would be positive 6 and positive 1. And so in factored form, we're looking at negative 2 times x plus 6 times x plus 1. And so by the zero product property, we would say x plus 6 equals 0 and x plus 1 equals 0 to solve. And we get x is negative 6 and x is negative 1. And so our points for our horizontal intercepts would be negative 6, 0, and negative 1, 0. Sometimes you won't be able to factor a quadratic, and when this is the case, we'll need to use the quadratic formula. So for a quadratic function given in standard form, which is ax squared plus bx plus c, the quadratic formula gives horizontal intercepts of the graph of this function at negative b plus or minus the square root of b squared minus 4ac all over 2a, making sure to first set the equation equal to 0 and then use the quadratic formula. It's important to note that if the discriminant, which is the quantity underneath the radical, is less than 0, there will be no real horizontal intercepts. For our final practice problem, we'll be looking at an application. A javelin is thrown in the air. Its height is given by the function h of x, where x is the horizontal distance in feet from the point at which the javelin is thrown. So h of x represents the height of the javelin, and x is how far away horizontally it travels from the point at which it starts. So we want to know how high is the javelin when it is thrown, which is technically where the person is holding the javelin. And so it hasn't been thrown yet, so it's still in the person's hand, and so the horizontal distance would be 0. That is, part A is asking to evaluate what is the height when x equals 0? And we get 6 from this, and that would be feet. So before the javelin is thrown, it's at a height of 6 feet. We want to know what is the maximum height of the javelin. That's going to occur at the vertex. The maximum or minimum occurs at the vertex of the parabola. So if you ever have a quadratic and you're asked to find the maximum or minimum in the application problem in the context, you want to find the vertex. And so the vertex formula is x equals negative b over 2a. And so we get negative 8 over 2 times negative 1 over 20. So we're looking at negative 8 over negative 1 over 10, and if we multiply by the reciprocal of the denominator, we end up with positive 80 feet horizontally. But we weren't asked how far it travels horizontally. What we wanted to know is what is the maximum height of the javelin, which will occur at this horizontal distance. And so what we want to do is actually plug the 80 back into the function. Using our calculator, we can see this is 645.99 repeating, so we'll round to 646 feet is the maximum height. Finally, how far from the thrower does the javelin strike the ground? And so the height of the javelin will be at 0 feet once it hits the ground, and so we want to set h of x equal to 0 and solve for x in part C. So we're looking at negative 1/20 x squared plus 8x plus 6 set equal to 0, and we're solving for x. I'm going to use the quadratic formula to solve. So we have x equals negative 8 plus or minus the square root of 8 squared minus 4 times negative 1/20 times positive 6 all over 2 times negative 1 over 20. That's because A is negative 1 over 20, B is 8, and C equals 6. So punching this into the calculator, we get two answers, either negative 0.747 or 160.747. Obviously, in the context of the problem, we're going to be looking at the positive number because distance cannot be negative, and so the javelin hits the ground when it is 160.747 feet away from where it is thrown. So if we wanted to round, this would be 161 feet. In the next video, we'll be covering polynomial and rational functions.